All right, good morning, everybody. My name is William. I'm from Texas Instruments. I'm General Manager for Taiwan and South Asia Sales and Applications. It's my honor to be here to talk about, to give the presentation, updating TI overall, and what the observation of this AI journey, the evolution of the power supply, and what we are doing here to provide a solution to support the new era to come. Let's start from an overview of TI. We launched 15.6 billion revenue last year, mainly coming from power and signal chain analog and embedded products. While a broad-based portfolio we have here, you can find our products across different market and different applications, across automotive, industrial, enterprise, communication, and others. First half this year, we run our business at about 8.5 billion, which is 14% year-over-year growth, with an observation of broad-based markets coming recovery in this market. And that, at this up cycle of the semiconductor market, plus the complex geopolitical environment, they add up a lot of uncertainty, right? So that reiterates the criticality of having the supply chain control, the capacity, as well as the resilience on the overall supply chain. Specifically for GaN, we have 6-inch GaN manufacturer in the US, and we have 8-inch GaN manufacturer in Japan. And we have also just recently successfully piloted 300 millimeter, which is 12-inch GaN in our in-house 12-inch manufacturing. With the the architecture of our GaN is GaN on silicon, and that allows us to have a good leverage. Our overall GaN's, our overall silicon capacity and system, including the 12-inch silicon wafer materials, the toolings, the equivalents, even the cleaning rooms. With some tweak on our production line, we can achieve good cost and also the capacity flexibility when we produce GaN on silicon. And the other thing about TI, we have 80,000 different products. We have a lot of a wide portfolio for power and signal chain and embedded processing. And we also focus on create a synergy between our existing product portfolio with GaN. For example, controller plus GaN, gate driver plus GaN, or audio class D amplifier with GaN, along with motor drive with GaN, right? So that synergy between our portfolio and GaN opens up a lot of innovative idea and to enable a smarter and greener world. That's the focus area we are working on, and to differentiate our products when we develop the products. And everybody knows that this is driven by AI, and it's also, but when we put together the numbers, it's always shocked, right, to see how much power has been eaten by this AI and data center. And it's now increasingly exponentially for demanding for more energy. And if we look at the market research, 7.6% of the power by 2030 will be consumed by this kind of requirement. And the other research I found is fascinating is not even the AI or data center, but even just the common human being usage of the chips. In 2015, each person on the world only consumes 33 chips. But until 2030, people believe we will consume 88 chips per person, right? So it's not just the AI or power or data center, but also see around us how many more chips we are using compared to 10 years ago, right? So this is certainly the trend coming to the nest. But while more energy and power is needed, it is absolutely demanding for higher efficiency, density, reliability, and certainly with affordable cost. We cannot just continue building more power plants, right? So efficiency becomes a must when we continue developing in this journey. And this is not just for high power I will talk about that later, but this is also about low power. We have customers, they do, for example, they tap USB Type-C PD adapter. They are also being asked by their end customer to produce extreme small form factor, like 37 cc big adapter with a wall mount architecture to deliver 65 watts. And in the past, if you use a discrete solution with silicon FET, it's hard to achieve such a small form factor with high efficiency and high density. But with our solution, GaN plus QR flyback integrated solution, we help the customer to achieve this target of the density and size of the form factor and the efficiency. And talk about high power, for sure. In the past, it's only 10 kW to 15 kW per rake. And we all learned that earlier this morning by recap by Dr. Jen, that the power is now getting to 150 kW, and soon will go to 1 megawatt, right? So apparently, it's a clear trend requiring for higher efficiency, reliability, and also density when we develop down the road. And the following pages, we'll talk more about the data center power architecture and how it's been evolved. And fortunately, my engineer's math matched to Dr. Jen's math. So that's good. We all see about 80% from this entire power path. And a bit more on this, starting from, and this is the architecture being developed starting from 1990s, but has been as the industrial standard for server power delivery for decades. A larger portion of power delivery is still adopting this configuration. It's from grid to mechanical transformer to 480 volt AC, and then going through all the way through server host, and it connects through a UPS to provide a battery backup and also stabilized AC power supplying into the server rack. And inside server rack, the AC power being rectified and step down to 12 volts, right? And then go to the voltage, the multi-phase power to enable CPU at the server. But the industry is demanding for higher efficiency. Why? Because the server is running at much higher power level, especially when cloud data center having increasing computing power and also the requirement which demands for a lot more power, right? So and that brings up the idea of Gen 2. And as you can see, the output voltage changed from 12 volts to 48 volts, or you see 50 volts in this picture. And the other one is the power supply along with used to be at the nest of the server plate, now being consolidated into power shelf layer. And that allows a higher density in the rack to support this incremental of the requirement of the power. BBU has also been introduced here as a local BBU to replace the UPS from the AC from the front line. And this BBU provides the backup power and also in certain level stabilize the voltage in between. And with this new topology architecture, it increased about 5% in the efficiency. Right? So while increasing the amount of deliverable power, this becomes critical of the 5%. And in this type of the Gen 2 power supply, it runs typically from 40 kW to about 150 kW of the power system. And we know that it's not enough, right? When we look at the next generation, people start to demand for 1 megawatt. And that requires even higher efficiency to achieve that. So people start to think about the next generation. And in this one, you see a couple of the change from our genius engineers in the world. One, while the density of CPU, GPU, networking switch start to occupy entire rack, the big and bulky power supply being pushed out of the IT rack, right? So there is the idea of sidecar, which is an independent power rack being introduced. But running the DC power from sidecar to supply to each of the IT rack if you still run at 50 volt voltage, DC voltage, from the quick calculation, it equal to 200 kilogram copper weight on the rig. So it makes it physically impossible to use 48 volts to support this 1 megawatt or even scaling in the future the requirement. And that's why people start to introduce 800 volts, or some people, they want to do plus minus 400 volts at this new architecture. And on the other hand, the PPU remains there while people add CPU to do an even better transient response, low transient response on the system performance. But this Gen 3 is something like ING that is under developing right now. A lot of genius engineers from system, from power supply, from chip makers are working together to achieve this Gen 3 concept. Couple areas being focused and being underdeveloped. And for our company, for example, there are two areas we focus more. One is at the DC-DC conversion. Oh, here, okay. Here, the DC-DC conversion, where when people used to do like 800 volt to 50 volt, and then 50 volt to 12 volt, two-stage conversion. Our engineer is working on a reference design to achieve from 800 volts to 12 volts directly. And we want to achieve this one-stage conversion to do a better on the power density as well as the performance on the overall on the board. And the other area our engineers are working on is at the sidecar, which is at the AC/DC side. We are working on the matrix topology to enable adapting with our GaN products, which integrated gate driver, to achieve one-stage isolated conversion at AC/DC. And we believe they will maximize the value of GaN by using matrix topology, and also meanwhile offer the best performance on the efficiency and overall cost in the system. And those areas are under developing right now, while we also work with our partners on developing these new architectures to enable this 800 volt Gen 3 architecture to be ready. So this is the summary page to summarize from 1990s, the Gen 1 traditional rig server to Gen 2, Gen 2.5, and what we talked just now about Gen 3 to support the next couple of years to come. And again, from this evolution, it reflects again and again, higher and higher power, lower power consumption is required, higher power density is being demanded, and the cost, for sure, affordable cost is always required, and the quality and reliability is being even more important when this market continues to develop. And all of this putting together is exactly the driving force when our engineers develop our GaN product solutions, how it applies to customer system, how they can resolve the pain point. That's the consideration when we work on our roadmap, which adopt our GaN solution. You know, with much higher, we already talked about a lot of good things about GaN, right, from this morning. And GaN certainly offers very high switching frequency. And a lot of benefit coming from that, but that high switching frequency also makes some design challenges. Like when your switching frequency go very high, EMI becomes an issue. How to avoid high-low side shows through when you're switching at that level of the frequency. And the parasitic inductance at the pass, at the switching pass, along with the parasitic capacitor with the GaN, it always results some noise and some design challenges. And that is something our engineers always said, no pain, no gain. But our goal is to develop our GaN solution for our customers to use that with no pain, right? So, and that's the goal. So, and this is our logic when we think about our GaN features, how we design our GaN integrated solution to help engineers to solve the problem. But in the meanwhile, maximize the benefit from GaN. First one, like as I emphasize all the time, integrated driver. When we are able to integrate driver with GaN, that put these two components into one package, they physically shorten the path, right, between driver and GaN, and so that the so-called parasitic inductance can be much reduced. And that help engineers to provide ease of design and higher reliability on the power switching system. Zero voltage detection, smart feature, and there is a feature that this ZVD feature, along with TCM, triangular current mode totem pole topology, which achieve zero voltage switching PWM control. And we already have a reference design proof the efficiency putting GaN, our GaN with ZVD feature in this TCM topology can achieve even higher efficiency at the high power control loop. And we do that benchmarking with silicon carbide. Integrated half bridge module with GaN, hydroxide GaN putting together with GaN FET, certainly they give a next level of the integration, and also the size of the density can be achieved. Mid-voltage GaN is another product we are very excited and has been very, very famous when our customers developing their BBU system to greatly increase the density when they achieve their BBU design. Last but not least, isolation and controller. This is a further level of the integration. Let's imagine, and that is something we have been working on. If we put QR feedback controller plus GaN driver plus GaN and plus OSDIX components integrated and plus isolation. And by the way, plus SR controller, put all these components into one chip. That is something we can achieve the next level of the density when our customer develop their low voltage AC/DC conversion. So this is our logic when we develop our roadmap and also how we define our product to really solve the customer's problem rather than just provide a single GaN solution. And this is something beyond. In addition to the optimization of GaN chip solution design, we are also devoted to develop total solution from AC to XPU at the system level. And we believe, start from the end to the beginning, right? We look at the system level, what's the pain point, and we optimize the overall performance and design. That's from PSU and BBU from digital control solution, how that interact and control with our GaN solution, high voltage GaN, mid voltage GaN, and going through the 48-volt E-fuse solution to have a more reliable system, and next go to the IBC module. Their mid voltage GaN being adopted, and along with monolithic switching regulators, right? At right-hand side, going down further from 12 volts to 1.8 volts or 0.5 volts to supply GPU or CPU power stage, which we also work with our partners in developing module solutions to give engineers additional options when they evaluate their design from AC to XPU. And again, we focus on not just the GaN solution itself, but also the entire system architect and how we can work with the customer to do more reference design and to provide ease of design and also more better performance on the system perspective. And this is a snapshot of, as an example of TI's overall GaN solution overview. But it's not all, but it's just a snapshot to give an idea on how that looks like. And this is from the left-hand side, a single GaN with integrated gate driver. And we offer different voltage. We offer D mode and E mode, different options. We offer QFN package and also industrial common footprint package, tow package. And we also have, as mentioned earlier, we have half bridge drive GaN with gate driver. And right-hand side, you can see we also have mid-voltage GaN with single GaN or dual GaN with gate driver. And you see at the bottom different version of the RDA sound being in the roadmap, while we continue expanding the footprint of our roadmap from more options for the customer to consider. Okay, and we talk a lot about GaN in AI, in data center, from the morning to now. But meanwhile, again, TI features a broad portfolio. and how we can better leverage our broad portfolio with our GaN technology. And that the excitement at this AI era is apparently not just AI data center, right? But across the infrastructure ecosystem surrounding the innovation. We are also developing our GaN into various applications to enable a smarter tomorrow. Leveraging TI's broad portfolio analog and embedded with GaN. For instance, I mentioned that audio amplifier, and that's exact a customer they are working with us on working on this Class D audio amplifier. In the past, it go with silicon FET. Now, with the cost of GaN and silicon FET parity, is getting very, very close, right? So this is really a very exciting time. In the past, we used silicon FET to integrate into solution. Now we can consider using GaN, and that achieve higher power, higher density, higher efficiency. And this audio amplifier is a fascinating example to myself that when we drive on the road with our car infotainment, the GaN enable another possibility. On the other hand, brushless DC motor control, right? When we look at humanoid robots, if you look at the small area that you need to have a very small form factor motor drive, this integrated solution, motor drive, control, plus GaN, make these kind of things achievable. So, and we are also working on this kind of integrated solution, motor drive plus GaN in a small form factor to enable extreme small applications. And also we talk about various of isolated and non-isolated topologies plus GaN, driver plus GaN, control plus GaN, and also a lot more possibility to be developed to enable an even more exciting future. This is my last page as a read-up that as the market demands more power, system designers strive for smaller systems with higher power density. GaN technology enables smaller, lighter systems with higher efficiency and power density to meet demands across a range of industrial systems. And TI GaN, along with the integration concept, deliver faster switching speed, high integration, lower system cost, and ease of design, ease of use into the new design. And last but very important, TI's internal capacity with the GaN on silicon that offers, and from Japan, from US, and also with the soon in the future, we have the 6-inch wafer fab, GaN fab, to offer our customer to support this exciting future ramp with geo-dependable capacity around the world. With that, thank you very much for your attention.